Hello students, today we are going to be talking about function families. Make sure you take notes as you go and don't forget to complete the survey in the end. A function family, there are 4 different types of function families that we're going to be looking at today. One of them is linear, the other one exponential, third one quadratic, fourth one absolute value. We've already seen linear and exponential, but we're going to introduce quadratic and absolute value today and look at the facts and details about each one of them. When we talk about functions, sometimes the equations are written in f of x equals instead of y equals. It means the exact same thing. You just need to keep in mind that f of x is the same thing as y. We will talk about the f of x notation at another time, but just remember that it means the same exact thing. So the first function family we're going to look at is the linear function family. Just like before, the equation for linear is f of x equals mx plus b. Again, f of x means the same thing as y, so it's still the same equation. We're just using f of x instead of y. Linear function family, this is what we look like. It's all straight lines, just like you've seen before. We have 2 different types of lines. We can either have a positive line or a negative line. If the line is going in an upwards direction from left to right, that means m is positive, so we're going to have a positive line. You can see the bottom 3 all have positive lines because the m value is positive. If the line is going in a downward direction from left to right, then m is negative, which means we have a negative line. So if that first number after the equal sign is negative, then we're going to have a negative line. Each function family has a parent function. This is the function that all other functions come from. It's the most basic function we can have. It has the least amount of numbers and the least amount of operations. In this case, the parent function for linear is y equals x, or f of x equals x. This is the most basic function we can have. All other functions come from this function. In order to find the y-intercept of the parent function, we're just going to plug 0 in for x. If we put 0 in for x, then we get y equals 0. This tells us that the parent function is going to cross at 0. This is important to remember later, so just keep this in mind. The second function family is the exponential function family. Exponential function family, we've seen this before. F of x equals a times b to the x plus c. Remember, we look at exponential function family when a is 1, so don't worry about the a, just focus on the b to the x plus c. Remember, an exponential function family means that x is an exponent, and it makes that curved line. We have 2 different types of graphs we can have for exponential function family. If we have the right side of the u, which are these bottom graphs down here, that means that it's a growth. So instead of positive, we call this a growth. That means that the b is greater than 1. So you can see all of these b values, they are all greater than 1. So anytime you have a b value greater than 1, we call that a growth. If you have the left side of the u, or the b value is between 0 and 1, so typically it's a fraction, but sometimes it's a decimal, then we have a decay. So instead of negative, with exponential, we call these a decay, and that is the left side of the u. With exponential parent functions, we actually have several different parent functions. A parent function can be any number that's raised to the x value. So we don't have an a value, or our a value is 1, and the c value is not there. It's just the b value raised to x. So anytime you have a number raised to x, just like you do in this one up here and this one over here, that is a parent function. The parent function, if we find the y-intercept, we're going to plug 0 in for x again. Anything to the 0 power is 1. So the parent function, the y-intercept, is 1 for exponential functions. Our third function family is the quadratic function family. Quadratic function family has an equation of f of x equals ax squared plus bx plus c. Anytime you have an 2 as an exponent, so it's x squared, you're going to have a quadratic equation. Quadratic equation is a U-shape. If you have a regular U-shape, that means a is positive, which means you have a positive graph. So anytime you have this upwards U, it's a positive graph, which means the number right after the equal sign is going to be positive. Anytime you have an upside down U, that means that the graph is negative. And that means you're going to have a number, that a value is going to be a negative value, that number right after the equal sign. The parent function for a quadratic function family is f of x equals x squared. So again, that's the most basic function you can have. It's very simple, and all other functions come from that. To find the y-intercept of the parent function, you're going to plug 0 in for x. So if we do 0 squared, we're going to get 0, which means the y-intercept of the parent function of a quadratic equation is 0. The last function family we're going to look at is absolute value function family. The absolute value function family is f of x equals a times the absolute value of x minus h plus k. The absolute value function family looks a little bit like this. You can either have a right side up V shape or an upside down V shape. If you have a right side up V shape, that means the a value is positive, which means the number right after the x or the equals is a positive. If the number right after equal sign is a negative, then you're going to have an upside down V shape, which means you have a negative graph. The parent function of the absolute value function family is y equals the absolute value of x, or f of x equals the absolute value of x. To find the y-intercept of the parent function, again, we're going to plug 0 in for x. The absolute value of 0 is 0. So just like quadratic and linear, the y-intercept of the parent function is 0. The reasons why we find the absolute value is so we can look at vertical translations. If we look at these different graphs, we want to see how far away the parent function is from the new function. So if we look at this first one, the linear function, our linear y-intercept of the parent function was 0, so we're going to start at 0, and to get to our new function, we're going up 2. So the vertical translation is 2 units up. You can also see this in the equation. It says plus 2, which means you're going up 2 units. For the for the exponential, our parent function has a y-intercept of 1. So if we start at 1, we're going down 1 to get to our new function. So we're going to go down 1 unit for the vertical translation. Again, in the equation it says minus 1, which means you're going down 1. For the quadratic, it was 0. So we're going to start at 0. To get to our new function, we're going up 4. So our vertical translation is 4 units up. Or we can look in our equation and it says plus 4, which means we're going up 4 units. And the last one, the absolute value, again the y-intercept was 0, so we're going to go down 2 to get to our new function. So we would go down 2 units. And again, in the equation it says minus 2, so that means we're going down 2. Characteristics of not a function. If you have two variables that are being multiplied together, it is not a function. If you have a negative exponent in the original equation, it is not a function. If you have more than one variable being raised to a power higher than 1, then it is not a function. And if you have a variable in the denominator, it is not a function. Don't forget, make sure all your notes are filled out. These will be very helpful tomorrow in class. Take the survey on the website and click submit. If it doesn't work, please try again later. Also, bring your questions tomorrow to class and we will get those answered. See you tomorrow.